Hi there, math fans. Quick video on divisibility tricks. I have a lot of people that ask me about this, and I realize quite a few students don't know about this, and so I just thought I'd make a video. There's plenty of things out there. I was searching around and I saw that so many people have divisibility tricks. I'm not really interested in teaching you, but I'd like to say a little bit about why they work. And I'm just going to choose a few numbers that I found online. My Aunt Tisha always brings these cheese balls to a party. The actual number is like 1,100, but I'm changing the numbers all slightly. This is the average number of M&Ms in a bag. This is approximately how many islands there are in the U.S. But people all the time ask me about divisibility things, and we do it so much that I thought it worth talking about a little bit. But really what I'd like to talk about is why these tricks work. And I kind of put them in green, which I think everyone knows, yellow, which some people know, and red, which very few people know. And the truth is, I don't know most of those red ones. I had to look them up. But I want to talk about why they're true. And maybe we can end by just picking a random other number and making up our own divisibility rule. Because that's what I'd like for everybody, is a little bit better sense. So first, please watch my video on congruences. Because that's a key piece to this. So for me, it goes back to a 52 card deck. I've played card games my whole life, and I know that two people can split up a deck evenly. And I know that I just have to look at the last digit. I know that 4 people can split up the deck evenly, and I know that 3 can't, because I've tried to play a 3-player game before. It all boils down to how the number relates to 10, because we're working base 10. So when we say 52, so a few little primers, we are saying 5 times 10 plus 2. And really what we're doing is trying to do is to find the remainder. And if you can free yourself to thinking in terms of remainders, it really makes things so much faster. It allows you to discard things. When it comes to multiplication, addition, subtraction, you can just replace the number by anything else that has the same remainder. This is really new for most people. For example, if you divide 10 by 2, your remainder is 0. If you divide 5 by 2, your remainder is 1. So this is why this works. We just understand this naturally. This is congruent to 0. This is congruent to 1. This is congruent to 0. So it's like we were doing 1 plus 0 plus 0, which is just 0. You do that naturally without even thinking. And you don't look at any of the other numbers because there's always a 10 in there. A 10 or a 10 squared or a 10 cubed. And the same goes for this M&M problem. 210 is 2 times 100 plus 10 plus 0. So really you're just trying to figure out which things are congruent to 0. It's really even better to think in terms of congruence because you can also think about what the remainder is. Okay? So for example, if I do 52, which is 5 times 10 plus 2, and I'm trying to play with a deck of cards, and I have 3 people, not only does it not evenly divide, I can tell you how many cards will be left over. And there's a very fast way to do that, because if you divide 10 by 3, how many are left over? 1. So this is the same as 5, and 5 could be replaced by 2. It has a remainder 2. This takes practice to do. But even if you didn't do that, this would be 5 times 1 plus 2, which is 7. But 7 is the same as 1. And so there's 1 left over. And you know that if you played with a deck of cards, if you try to deal out 3 piles, there's 1 card left over. That's the sum of the digits rule. And the reason the sum of the digits rule works for 3 is because if you divide 10 by 3, and when I was a student, we had to write a little R1. There's 1 left over. So 10 is the same as 1 in the eyes of 3. It also works for 9. So some people haven't seen that. That's particularly useful the 2s, the 3s, the 5s, the 9s. All of those numbers are very easy to work with because of their relationship to 10. 2, 5, and 10 all evenly divide 10, and 3 and 9 all evenly divide the number 1 less than 10. Okay, so if you didn't know that, you would know immediately that this is divisible by 3. And you know immediately that this is not divisible by 3. We would say it's 1 mod 3. There's 1 left over. And we would say this is 0 mod 3. And it makes it so easy to see. I mean, I can just look at this. This is one I use all the time. And I can see it's divisible by 3 because those two digits add up to 3. And you can even play around with it. If you change this to a 6, still divisible by 3. So I find that not very many people know that. It's not divisible by 9 because 3 is not divisible by 9. But if you change this to a 6, it would be divisible by 9. Just the sum of the digits. So I think everyone should know that. And while I'm talking about that, you get 6 for free. So something is divisible by 6 if it's divisible by 3 and 2. So for some of these numbers, you don't need new rules. You just need to know how to factor. This is 2 times 3. 12 is 4 times 3. 15 is 3 times 5. 18 is 2 times 9. So you can quickly check things like this one. This one's divisible by 2. I can tell just based off the last digit, so it's even. Or we would say it's congruent to 0 mod 2. And it's divisible by 3 because the digits are divisible by 3, and that means it's divisible by 6. So you can see we've chunked off, if I'm just sort of keeping track here, a large portion of numbers can be done in your head very quickly. And I would throw, 4 is fairly quick to do because you just have to look at the last two digits. Online, most people say you just have to check the last two digits. If I was going to do it, I would just divide by 2 twice. Divide by 2 is 26. Divide by 2. Okay, it's divisible by 4. So to me, I would do half. If you divide by 2 and it's even, then you're done. So I would consider that very quick. So you can actually check quickly if something's divisible by 12. Okay, we can do that right here. Let's do half. So half of this, or you can just look at the last two digits. Here, last two digits is faster. That's not divisible by 4. So no, it's not divisible by 12. I hope this is okay. Like I said, I'm not really trying to teach you. I'm just talking through how I think about these. And then we'll get to the more complicated ones, and then I'll try to generalize. Okay, so if I change this to a 500 and not 12, 6. So let's say there were 216 M&Ms in our bag, and we wanted to try to divide it up between 12 people. Can we? Well, first, is it divisible by 3? Yes, because the digits add up to 9. In fact, it's divisible by 9. So we could say it's 0 mod 3, and we could say it's 0 mod 9. What else is in there? Well, let's see. You can do it's divisible by 2. It's also divisible by 4 because the last two digits are, or you can do half and half again. So it's congruent to 0 mod 4. And that means you get several other things for free. Meaning it's divisible by 6 because of these two. It's divisible by 18 because of those two. It's divisible by 12 because of these two. It's divisible by 36 because of the 9 and the 4. Okay, so there's kind of, I would say the majority of the time that's all you need, and you can handle all of these. So let's black them out. I hope you're completely happy with divisible by 2, by 3, by 4, by 5, by 6, by 9, by 10, by 12, by 15, and I think 20 as well because it's 4 times 5. So you're left with these few. An 8 is the same idea. You have to look at the last 3 digits, or you can do divide by 4, So let's do that as well. So there's a few other ones to talk about. 16 is also a power of 2. So you look at the last 4 digits, or divide by 4 again. So I'm going to leave that off too. So what are we left with? A few interesting. So we need to talk about 11, which I think everyone should know. And then we'll talk about these ones that don't as naturally have a good relationship with 10. Okay, so let's erase this and make a fresh start. It's good to make sound effects when you're killing time. Okay, here we go. So now I'd like to talk about 11. 11 has a nice relationship with 10 as well because it's one more than 10. So if you do 10 mod 11, this introduces another idea or trick. 10 is the same thing as what would be something that has remainder 10. It's the same thing as 21. Because if you divide 11 into 21, it goes in there with 10 left over. But 10 and 21 are both pretty big numbers and aren't that friendly to work with. So what we do instead is we go the other way. We subtract 11 and we get negative 1. So it turns out subtracting 1 or adding 10 do the same thing to your divisibility. Here's what I mean. So let's say you have 23. If you add 10, it's going to be 33, and that's going to be divisible by 11. But you could have also subtracted 1, and that's also divisible by 11. So instead of adding 10, we can subtract 1. Okay, so the point of that is if you have a number like 52, which is 5 times 10 plus 2, you can treat 10 like negative 1. And you can do negative 5 plus 2, which is congruent to negative 3 mod 11. And the fact that this is not 0 tells you this is not divisible by 11. What about 210? So that's going to be 2 times 100, which is the same as 10 squared, plus 1 times 10 plus 0. This is the same as negative 1. This is actually the same as negative 1 squared, which is positive 1. So you get 2 minus 1 plus 0, which is 1 mod 11. That's not divisible by 11. Many of you probably know that 121 is divisible by 11, and it has this nice property of 1 minus 2 plus 1 is 0. So a lot of people haven't seen that. It makes it very easy to check for divisibility by 11. You know, for example, if somebody gives me the number 1313, I know that it's divisible by... Is that divisible by 11? No, it's not. That's not the number I wanted to draw. I wanted to do this number. So if you do 3 minus 1 plus 1 minus 3, you get 0. It's divisible by 11. That's pretty slick. Okay, so we've kind of dealt with all these. The other thing you should know is that once you've found a few of the factors, you're completely done. We knew this was divisible by 4, so this is 2 times 13. And that's really the best way to know what the factors are. That's the unique way to factor it. So it's divisible by 2 and 13. And that's it, but we'll come back to the 13. This one is the same as... so we already figured out it's divisible by 3, and we'll find out in a little bit that it's divisible by 7. It's divisible by 10, so it's divisible by 2 and by 5. Oop, my 5. That's called the prime factorization, and I'll check some of my work here in a second. But I wanted to talk about the other divisibility tricks. And if you've never seen this before, it really all comes down to congruence. So 11 has this alternating trick. And now let's talk about the other ones. And the other ones I haven't encountered very often. So before I made this video, I looked up some of them, and I'd never even seen some of them. So like I said, I shouldn't be teaching them. But ultimately, once you get to something else where the relationship with 10 is not so nice, then you have to think about what we would call inverses, what you have to multiply by to make it a nice number relative to 10. Okay, so here's the thing. what we mean by the inverse is what would you have to multiply by to make it 1? So interestingly, when we're talking about 7, if you do 10 times 5, you get 50. And if you divide 50 is 1 more than 49, so there's a remainder 1. So there's a whole important part of arithmetic where we talk about inverses. It's kind of like multiplying by 5 is almost like dividing by 10 when it comes to 7's perspective. Now 5 is still a pretty big number. So there's another way we can think of 5, which is we can think of it as 2 less than 7. So this gives us two ideas. If we multiply 10 by 5 or 10 by negative 2, it will make it 1 in the eyes of 7. How in the world is that useful? So the methods is this, and I don't use this very often, and I don't know, the bad part about these methods is if you have to think about it, then you're kind of in trouble. But thinking in terms of congruence, you could always do. So for somebody, I would see it's divisible by 7, but you can think of it as 100, 2 times 100, 1 times 10, plus 0. And you could use this as this trick says to take the last digit, double it, which in this case is 0, and then just look at the remainder. Just look at 21. So in that case, it was really fast, and you can see that it's divisible. But let's look at another one. Go to the next one, because the ideas for all of these are the same principle. Okay, so let's try this same principle here. So let's say we have 1,274 cheese balls, and we want to divide them up. Can we divide them up between 7 people? Let's try it. So we're going to think of it as 1 times 10 to the third, or 1,000, plus 2 times 10 squared, or 100, 7 times 10 plus 4. And we're trying to check divisibility by 7. So the actual reason it works is because we think of multiplying this whole thing by 5. And what it's going to do is the 5 times 10 is going to be the same as 1 mod 7. I know it's kind of higher level stuff. This is going to get rid of one of the 10s here and one of the 10s here. But there's also going to be this 5 times 4. And the other principle is multiplying number times 5 is not going to change its divisibility by 7. So if you had a number that's not divisible by 7, what would be 112? And you multiply times 5, it's still not going to be divisible by 7 because that doesn't change divisibility. So inserting the 5 doesn't change the divisibility principle of it. Okay, so anyways, this is the same as 10 squared. 1 times 10 squared plus 2 times 10 plus 7. So it's made the number smaller, and that's this part about the remaining digits. And then we're going to multiply not by 5, but it says double the last digit and subtract. If you look online, that's what everyone suggests. Doubling the last digit and subtracting is like multiplying by negative 2. So they're multiplying by 5 in a clever way. The other way you could do this is just multiply times 5. But so we're going to double it and subtract. So this is going to become negative 8. So what they're saying is do this. And I've never even actually thought about this before because I always do it directly with the congruence. But they drop the last digit, they double it, and they subtract it. And that gives them a new number. And it turns out the new number is congruent to the old number, mod 7. And so if it's divisible, still going to be divisible. What would this be? This would be 119. See, I don't like to have to subtract. And then you can check if that's divisible by 7. Rinse and repeat. Meaning, take the last digit, double it, and subtract it from the remaining Now, in this case, it's interesting because when you subtract, you're going to get a negative. So I think what you're supposed to do is to take the difference. So the last digit doubled is 18. And so we want the difference between 18 and 11. And that gives you 7. And 7 is congruent to 0 mod 7. So it is pretty slick. It's just maybe hard to remember. But the way you would remember it is think about what the inverse of 7 is. Unfortunately, it's either 5 or negative 2. But we just learned, yes, we can divide up the cheese balls between 7 people. We found one of the factors. We also can see it's 2 as a factor. This is divisible by 2. Is 74 divisible by 4? I think not. Because 76, half of 76. See, I'm not very good at this. Is it divisible by 3? Let's see. We add the digits. We get 3. We get 10, 14. It's not divisible by 3. So I know there's a 2 and a 7 in there. Okay. Let's leave it at that because we're going to keep going. But so far we know there's a 2 and a 7 in there. Pretty slick. So when I started to look at these other rules, I was like, oh man, these are all weird. I never had seen divisibility by 13 or 17. I put 14 in red because in order to figure out 14, you would have to know 7. 7 and 2. So this is divisible by 14. So it's no harder than doing 7. So let's pick one of these other ones, 13. So when you look online, it says multiply times 4 and add it. So now you know probably why. They said, well, what happens, what is the inverse of 10 mod 13? How do you get rid of 10? And based off of what I found online, I bet it's 4. Now, if you didn't know what it was, you'd have to keep checking. But this gives you 40. And 40 is 1 less than 39. So there's a remainder 1. Same strategy. So we're going to take the cheese balls. 1 times 10 to the third plus 2 times 10 squared plus 7 times 10 plus 4. And we're going to multiply everything times 4. Ah, that's where they got that number. What that's going to do is it's going to turn 4 times 10 is basically 1 mod 13. And if you're new to this, again, this is going to be hard, but at least I'm giving you this idea. Take a course in number theory or abstract algebra. And then we're going to add 4 times. So why are we adding this time and not subtracting? Well, because here the inverse was negative 2. Here the inverse is positive 4. So this is 16. So let's play the game. So we're going to do 1, 2, 6 plus 16. This time we're adding. It's going to be 3, 1, 4, 1, 143. Rinse and repeat. 4 times the last number is 12. So we're going to do 14 plus 12, which is 26, which is divisible by 13. I did go back and tweak these so to make sure. So this is divisible by 13. At this point, I'm wondering if we have all the factors. That's pretty close. No, it's not quite there because 14 times 13. So there must be another factor in there. Cool. So now you know the idea for all of these. So you can probably guess at what the inverse of 10 is. Mod 17. You say, no, you lost me 10 minutes ago. If I lost you 10 minutes ago, you're not still watching. But I hope this has been interesting. And let's say a couple more things. Sorry about my erasing. So if you're talking about 17, it says do 5 times the last digit and subtract. So that makes me guess that this times negative 5. Or in other words, again, I've thought of congruences a lot in research I did in grad school, so that's why this is quick for me. And also I did computer science, and this is helpful for that as well. But another way to say this is 5 from 17 is 12. So I bet this times 12 gives something that's 1 less than a multiple of 17. But negative 5 is easier to work with. So take the last digit, multiply times 5, and then rinse and repeat. And I should note, I was going to show you some of my work, make sure I didn't, if you go at any sort of online calculator and say factor, so here's factor 52. That's not going to be surprising. Oops, let me get that ready for us. Usually I don't even type. Factor 52. It's 2 times 2 times 13. Factor 210. 2 times 3 times 5 times 7. That's kind of nice. I don't know if M&M does that on purpose. You can divide up your M&Ms between 2 people, 3 people, 5 people, or 7 people evenly. Or like I do, you can dump the whole thing in your mouth. Okay, so let's factor 1, 2, 7, 4. Ooh, that was a prime, not what I wanted to type in. Ah, there's 2 7s in there. Didn't notice that. So it would have been, we would have had to look for the other factor. At this point, I would have probably divided some out. Okay, so let's maybe peek at a few other numbers, some bigger numbers. I just looked online for some interesting bigger numbers. This is the number of islands in the U.S. approximately. I increased it a few so that the number would be nicer. This is the number of islands in Norway, which is the country with the most islands in the world. And this is the total currency last year in the U.S. And I added a few digits to make it work out. So now you know how to test these things. Now hopefully you can look at a number. And to me, it's not even. This is my first observations. It's not easy. Is it divisible by 3? Well, let's add the digits. 9 plus 6 is 15. Plus 2 is 17. Makes 20. Not divisible by 3. So in a matter of moments, you can check that for these things. This is even, so you can factor that out. And this is even. Is the last two digits divisible by 4? No, because 60 is. So that's just even and not divisible by 4. 90 is not divisible by 4. So we've started to break these things down. 2 times something, 2 times something, and there's no other 2's in there. Is there a 3 in this one? Well, we're talking 3's. So 14 plus 13. 14 plus 13, so 27 is divisible by 3. It's also divisible by 9. Okay, and let's do the next one. 4, 13, 20. I'm just adding the digits if you don't know what I'm doing. You're probably doing it faster than me. 13, 20. And the truth is, at any point in adding the digits, you can... Well, anyways, let's keep going. 13, 20, 24, 27, and 11. 38, so it's not divisible by 3. So no 3's. And this one was no 3's. So there's no... In the top two, there's no 5's. I can see this is divisible by 5, so let's put a 5 in there. And we're just slowly building up the factors. 6, this is divisible by 6 because I had a 2 and a 3, but I don't need to check that. 7, we can use the trick. Now I have to remember, so this is not helpful. 7 was the number we used, the inverse we needed, but if you did it a lot, it was double -2. Double the last number and subtract. So if you did a 7, you double the last number and subtract. So I don't know if I'll do that again. I'll leave that to you. Let's check some of the other ones. Maybe a 17. I don't remember. I know that one of those is divisible by 17. Maybe I'll cheat. Let's cheat. This is a terrible demonstration. That's divisible by 11. Oh, I didn't check 11. I meant to check 11. 11's also easy to check because you can do 3 minus 2 is -1. So you make these negative and you make these positive. That's the 11's trick. So you would say 1 minus 8 plus 6 minus 2 plus 3. So it's -10, and then there's a 7 and a 10. So it's 0. It's divisible by 11. So I already know there's an 11 in here. You can check this one as well. So we need to have this be a minus, this be a minus, and this be a minus. The ones are just always the plus. So the other way you can do it is just alternate and say, well, that's 11 if you add the positive ones. And the negative ones are 14 and 2, which is 16, which is -5. So the answer would be no. And this one, can we divide up the money between 11 people? Boy, that'd be nice. I'd like to be one of the 11, but it's going to be negative, 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 negative. It's just surprising how quickly you can do this. So here we go. Well, let's just do this as we go. These two are 0. These two make 2. These two make -2. These two make -4. That's -6. These two make -1 and -9. So altogether, that's negative 11 and negative 5, which is negative 16. So the answer is no, it's not divisible by 11. Okay, so now we're down to the trickier ones. And let's see. So this one would have been kind of challenging because it's the other divisible number is 1693, which is a prime. So that would have been tough because we would have been testing for a while and realized that nothing else divides it. 5, 8. Okay, so this one says that not only does 3 and 3 divide it, but another 3 does. Oh yeah, we said it was 27. It says 19 divides it. So let's run the 19 experiment. So what's the inverse of 19? Apparently it's 2. Let's check that out. That's actually easy to figure out. Because that's 20, which is the same as 1 mod 19. So multiplying by 2 and adding. So let's play the game. 2, 3, 9, 0, 5, 8. We're going to extract the last digit and double it. 16. And that, now I'm starting to build up a method here. All right. So we go 1, 1, 2, 9, 2, 3. And let's play the game again. Subtract the last digit and double it. So that's going to be 2. Add it on. That's kind of fun. 2, 3, 9, 4. Extract the last digit, double it, add it on. Ooh, I kind of like this. I wish I would have known this sooner. All right. Extract the last digit, double it. That's 14. Add it on. All right. 38. Is 38 divisible by 19? It's 2 times 19. But let's keep going. Take the last digit, double it, 16, add it together, you get 19. All right. That was fun. All right, 19 does divide that. Pretty slick. Other ones, 2, 2, 9, 7, 4, 0, 3, 2, 9, 0. That's divisible by 17. So if the person watching wants to try, they can check divisibility by 17 and 13, and it actually works on that one. To finish this off, we could pick a random other number, and I didn't prepare this. If you want to check divisibility, you need to figure out the relationship between that number and 10, and maybe you want to find the inverse. So I don't know what to pick next. 29. I think 29 is a prime. So develop a method that's a shortcut for dividing by 29, if you can think of it. And that would involve trying to figure out the inverse of 10 mod 29. 10 times what makes 1? How can you cancel a 10? And you can see it's 3. So I know the technique. The technique would be to do 3 times the last digit and then add to the remaining. I've never seen that before. So there you go. If you can figure out, it's all about figuring out the relationship between the number and 10. If you're really interested in that, the arithmetic that arrives from these things is studied a lot in a course called Abstract Algebra, which is sort of a vital course if you want to go into upper level mathematics. You also just use this all the time in cryptography and number theory, which is why I know it so well. All right, hope you found that interesting.